Yeah, we're all here.
Yeah.
So we have another group of designers.
Okay,
I will
sir.
give a small introduction in terms of what today's session will be. Yeah.
Make sure you can see clearly. Do the commands and all these things. And in the beginning, half an hour, it will be a little boring.
Yeah.
Why? Because you know all this stuff. And you don't want anybody to go to sleep. Okay? Because I'll be taking a test at the end of this session.
Okay, I think, Srija, I think we're ready. We can start. Yeah, I mean, on the initial session, on the initial part, we'll probably give you, some feedback in terms of if it gets too boring and people understand everything, we probably want to jump a bit, But beside that, we repeat the same as we did yesterday.
Yeah. Okay, so just in case if you come up with any topics that you feel is not required, you can just tell me and I will skip it.
Yeah, we'll do it on the go. Yeah.
Okay.
And anybody
Okay, so
will ask any question.
so today's section is like an introduction to SolidWorks. Today we will be covering 3 modules. In the first module, as introduced, it will be a little boring. It will be a little bit of theory, introducing the basic terms.
Yeah.
But we will come again in the training as well as in the software. We'll be encountering these terms. And in the second module, we will be going through basic sketching. That will be part of theory and part of practical. And the third module will be completely practical. There we will be learning how to create a new part, how to give appearance to it, and how to make a drawing, associative drawing out of it.
Yeah.
So let's start. So in our first module, we will start with the definition of SolidWorks as earlier.
Yeah.
So SolidWorks mechanical design and automation software is a future-based parametric solid modeling design tool.
Yeah. Do you want to share your screen?
Yeah, I forgot. I'm sorry. I'm used to classroom training. Yeah. So SolidWorks, as I told, SolidWorks is a future-based parametric solid modeling design tool, which take advantages of easy-to-learn Windows graphical user interface. So you can use the you can create a fully associative 3D model with or without using constraints and relations. So this is an explanation about SolidWorks.
Yeah.
So now we will be going in depth about what are these terms, what do they mean. So like for our first time, we told that SolidWorks is a future-based software.
Yeah.
So what exactly is future-based? That I can show you with a. So most of our people will be familiar with this, but again, I'm forced by the curriculum to say that.
No, it's cool. No worries.
Yeah. So as in an assembly, all will be familiar with the concept of assembly. As an assembly is made up of different small components and small and big components. Same way, a 3D model in SolidWorks is made up of components called features. The features can be sketched features and applied features. I'll be showing you what is a sketched feature and an applied feature, and I'll be showing in detail how this is created, but this is just to show what a sketch feature and applied feature. My SolidWorks is coming up. Yeah. So I will change my screen that I'm sharing. Go to SolidWorks. So in SolidWorks, there are certain features that require a sketch to be created. Like I need a square sketch here to do an extrude. So extrude is a sketched feature.
Can you all see clearly the commands? Sanjay, you can see all right on the top?
Yeah.
Yeah, we're here, man.
Yeah. So now I have created an extrude from the sketch. So this extrude is a sketch-based feature. So it's a sketched feature. So, but in case of a fillet, we don't need a sketch. We directly apply it.
Yeah.
So it's an applied feature. So these are applied and sketched features. Just for your understanding, we'll be going in detail about all these things.
Yeah. So just to point out. So when we say feature-based, what that means is that you're having a model or an assembly and you make it out of small bits. So for example, if you did a sketch, that's what we call a feature. If you did an extrude, that's another feature. If you did a radius, that's another feature. So what you do, you just stack one on top of another. That's what's feature-based. And all those features are connected with them, based on the shape you're doing, mathematically, essentially. It's all defined mathematically. But that's what feature-based means.
Okay. So now you're seeing my PDF, right?
Not yet.
Yeah, now.
No, it's not coming up yet.
Let me reopen it. I don't know. We had the same issue yesterday.
Yeah, no, it's gonna. I think it's better if you share the entire screen and then just swap in between on your side. So
Yeah,
then,
I will make it screen.
yeah,
That will be better. Yeah.
yeah, that's better. Yeah, now we see it.
So next term is parametric.
Yeah.
So this is a general term that always comes up. Like it says that it's a parametric model. So what do the term parametric means? Parametric means that for creating this model over here, I have created a sketch. And in that sketch, I have given a dimension. I've given it 45 and I've made this as 60 and I've closed the sketch. So at any point, I can go back to the sketch, edit it, or I can get this information back at any point. This is parametric. This is the future parametric, or I can change it to any value.
Yeah.
Accordingly, my model will update. So this feature is called parametric. So our software is capable of saving the information like dimensions and relations that I used to create a particular feature.
Yeah. So when you have something that you designed and you make a drawing for it, it's all, kind of linked together, right? So when we say parametric, what that means is that, you have a definition, but any point you can go in and change the definition, and that definition will reflect across everything you generate. So for example, if you did a drawing, of something and you want to change something, you have to change all the views, all the dimensions, everything. Here you just go in, change whatever you need in terms of section or sketch or whatever, or position of a hole. And when you do that, it reflects that across the entire part, entire assembly, entire set of drawings, right? So it's all linked together.
So I have also told that it's a solid modeling tool. You people will be familiar with the term solid model. It's a geometrical model used in CAD systems.
Yeah.
So it will be having surfaces and wireframes enclosing a volume. That's a solid model. So we'll skip on the topic.
Yeah.
And it's fully associative. What do we mean by fully associative? So I have created a model over here. Fully associative means wherever I am reusing this model, if I am using this model in an assembly or in a drawing, it is connected to that particular drawing or assembly. So I'm going to make a drawing of this model. I will just save it as part 1. And you can see here, I will open a drawing. I will just drag this in. So what do we mean by associative? So if I check the dimension over here, now I will check the dimension. So this is the same 90 I have given in the model. It doesn't mean it will be 90 or if I go and change back in the model, you can see that it will automatically update. So there is no manual intervention required to change or update things. And so once I change it, I go back to the drawing. I will see it changed in my drawing as well. So there is no need to do it manually. Vice versa, if I change in the drawing, it will be changed in the model as well. So we will be seeing this in detail in the next topics, next modules. So this is the associative feature.
The funny part, it goes both ways. So if you change the dimension on the model, it's going to appear on the drawing, but maybe it's not self-intuitive, but you can change the dimension on the drawing, and then it's going to appear on the model. So it goes both ways.
Yeah. So next is the term constraints. So in SolidWorks, like we apply dimensions, we can also apply constraints, and we can apply constraints like coincident and up to point, and all these constraints can be applied. We can use constraints. And as you are designers, there is no need to explain the term design intent, right?
No, that's cool.
Okay. Yeah. Automatic relations. So what is automatic relation? So
we can just touch the subject of the design intent. So design intent essentially means that when you design something, you're designing it for a certain product, for a certain production process. So if you have a milling machine, you're going to dimension it differently than you do when you have another process. So design intent is just reflecting what the part is and how you want to produce it, right? So it's like, how do you model a part and how do you dimension it when you have a different type of process? Where if you 3D print a part, it's going to be different when you mill it or when you do it by hand, right? So that's design intent.
Yeah. So SolidWorks helps you with automatic relations when you create a sketch. So that we can see here in this model. So if you go back to the sketch, you can see here it have automatically put some relations here, constraints here. Let's see, it have shown that this line is vertical, this line is horizontal, and this line is vertical. So I haven't applied this. This was automatically applied by SolidWorks by the way I was sketching it.
Yeah.
See, it is automatically giving me relations and constraints.
Yeah.
And we can use equations.
Yeah.
Equations in the sense, if I am using this dimension over here, I can use it equal to this particular dimension. I can use it like this.
Yeah.
Or I can also define equations over here. I can insert equations. I can add a new equation and I can assign it to a particular value. And once I update it here in the sheet, that we will be learning in detail in the future modules. So when I change it, it will be automatically updated. So now this, when I go and change this particular value, if I change this 60 over here to 80, this will automatically update to 80. So we can use equations. It can be done in a detailed way as well. That will be explained in the future modules.
Yeah. So what's new? What's new when you transition from 2D to 3D is that you have constraints on the drawings, you have equations and other things that are now linked to the design process that were not existing before. But there's a lot of other functionality that we're going to see in the future modules going to training.
Yeah. So next is dimensioning capabilities or dimensioning we have already seen.
Yeah.
This is a picture showing the design intent of a particular stuff. This Mr. Dejan have already explained.
Yeah.
So according to the manufacturing process also, so if we are going to make it for turning, it will be a different process. If you are going to make it out of casting, then the drawing will be defined in a different way. That we have already explained. So file reference. So file references, that is what I told yesterday. So Mr. Dejan, do you want to include like adding a PDF file into the SolidWorks file? You're going to have manage, right?
Yeah. So we can essentially put a link for a PDF. So if you imagine, like for example, the automotive or aerospace industry, they have a bunch of parts. And what they're struggling with is the move of data, right? So what's the kind of like the trend at the moment is they want to move one file for one part. They don't want to move a model, a drawing, a this and that, because then when this stuff is moved, it's usually moved by purchasing people, which are not technically capable to understand that information. So So what they have a tendency of doing is attaching as much information as possible to the actual 3D file. So in here you can connect a link for a PDF file, for example, which could be a drawing or something like that, you know. So that's the intent behind it, but we'll have a system that will manage that, and I think this functionality won't be needed.
So anyway, just to show, you can have insert an object.
Yeah.
So you can have different file formats. You can see over here. It can be a Word file, it can be a PDF file, and different sorts of files can be incorporated to a model. So for example, we are selecting an Adobe file.
File, just so they see what the outcome is.
Yeah. Insert object. So while inserting, we have two options. We can bring it as a complete file, or we can just keep it as a icon that we will double click and open it when we need it. Okay, and we will select this. It will be a bigger file. For example, I will select this file. So I have this as a link in my model now. Whenever
Yeah.
I want, I can go and click on this link and I can open it.
Yeah.
So this is the same file I have opened here for training.
Yeah.
So this is file references. We can add references to our model and use it later stages when we need it. It can be of multiple formats. And this is for general understanding. When we are opening SolidWorks, a file in SolidWorks, what happens is that the entire file is copied to a RAM. So if it is a bigger file, or in the way in which you are opening it, if you are opening it in a light mode, then if it is assembly, the particular subset of that is loaded to the RAM. And if you are opening a model according to the graphic settings and visual settings you are setting, that much data is loaded into your RAM. So this is something you should understand while working with your SolidWorks. So this also is an stuff that will be useful for you in the advanced stage. Just understand that SolidWorks is a RAM resident software. So that's our topic, and now let's get into SolidWorks user interface. So as we can see here, so this is our general SolidWorks user interface. First of all, we are having menu bar over here. This area is called the menu bar. In the menu bar, we will be having different pull down menus. So if you are going into, I will open a new file so we will have more options. Yeah. So we are having different pull down menus. First, we are having a file menu. So this is the menu where we use to open a new file, open an existing file, close a file, make a drawing out of an existing model, make an assembly out of an existing model, save as, and these commands. And we are having additional commands like this is the tab we use to create a 3D PDF as well if you need it, and we can print from here. And for when you are working with an assembly, when you want to go pack and go, this is the same area where you do that. And edit is generally the tab where we used to edit, copy, paste, and rebuild, suppress, and such component features are there. So all these things can be seen in the later stages when we use it, because when I say it, we can edit, copy, you'll be thinking like what, it is not a Excel file we can edit and copy. So we have the same functionalities in SolidWorks as well, and that will be demonstrated later. So the view tab is what controls the view of our SolidWorks. So how we are seeing the SolidWorks. So we can split the screen, we can record the screen, we can change what sort of display we are seeing of the model that we are having. For example, so in view tab, in display, we are having multiple sort of displays. We don't have to go in this place for always changing the display, just showing what we are having here. everything that we are having in these pull down menus are also kept in shortcuts in different locations. But these are the area where you can specifically find that. So this stuff are customizable. If I don't want a particular tab in this, that can be removed. But this in this pull down menus, you can find all the commands that you want. And insert is the area where you will be inserting something new into SolidWorks. It can be a boss, it can be a feature, it can be a pattern, fasteners, surfaces, faces, whatever you want to insert into SolidWorks. That can be done in this area. And tool is basically a lot of things that we will explain one by one. And it contains multiple tools that are being used in SolidWorks, from macros to evaluate tools like and defeaturing and selection tools. So many things reside in the tools bar, and simulation is a tab when you are using simulation processes. So you are having one SolidWorks premium license, right, sir?
We have 2 premium and 3 pro.
Yeah. So you will be having simulation capability. So
yeah,
you're having simulation training as well, right? So
that's correct.
yeah. So and Windows is the tab where you can jump between 2 windows. So for example, if you're working in 2 different models or working between the same model and its drawing, window is the place where you can jump between that. I'll be opening a new tab and I'll be demonstrating that. The bad part about the online training is that I can't even understand why when my students are getting bored.
No, it's okay. Don't worry. Yeah, we're still following.
So now I'm having 2 tabs where I'm having 2 different parts. This is where I can jump between those 2 tabs.
Can I stop you for a second? So I mean, so it's very hard for him to do a presentation as well because he's just gonna run through, So if there is anything that you want him to do, or you want to ask a question, if you want to have a specific, model done or something like that, that you just want to experience, to understand how it works, he's there to support. Yeah? Otherwise, it's going to be hard for him and it's going to be hard for you, because it's going to get boring.
It will be better as an interactive section. When you are seeing this, I would suggest if you have a SolidWorks open, then it will be better. When you do something, if you try it, it will be better in the meantime.
We'll organize that for the second session. Unfortunately, for the first one, we can't do that.
Yeah, that's fine. That's fine. So we were in the Windows tab. So these are the pull down menus and these are the functionalities that we are having here. We can have multiple tabs and we can see it in vertically, you can split it vertically, and the different functionalities can be done from this Windows tab. Then the most important one that we are most commonly going to use is our command manager. So what we are seeing here are the command managers. So it contains basically each command manager contains different commands. So this is so if you are seeing here, this particular command manager over here contains the commands for creating a sketch, defining it, editing it. It can be a 2D sketch as well as a 3D sketch. So this is the command manager that contains the features for creating a 3D model or adding an applied feature to a 3D model, to edit the 3D model, to do different operation, to pattern, to mirror. All those features are here in this features tab. And in the surface tab, similarly, you will be having options to bring up surfaces and such stuff for 3D modeling. And there are additional modules for sheet metal and all. If you're into sheet metal design, there is additional functionalities that help you in creating sheet metal parts. You can be like it is far more easier than creating in a conventional way or doing it in a 3D. The software automatically helps you in creating both the bended form as well as the flattened shape, and manufacturing, drawing, and all will be easy using the sheet metal module. So basically all the different tabs contain commands to do different operations. So this is another important tab that comes in handy for me a lot as I was working earlier. It helps you in evaluating so many things, and this is a tab that is most underutilized, but it is a very useful tab. You can check the weight of a particular component, the center of gravity. You can measure a particular value from here. You can measure a value, it doesn't matter. You can measure it in 3D as well. So evaluate is basically a tab for collecting data and different sort of data. You can do a thickness analysis, you can have a symmetry analysis, different things can be done. So these are not only the tabs that we are having, there are multiple tabs that are even hidden. So for example, I'm a 3D, I'm not into simulation, I'm not into sheet metal, I don't want to bring all those things. I can hide it. Whatever tabs I don't need, I can just hide it. I can only work with the tabs that I need. So you can right click on that, bring tabs, remove the tabs that you don't want. Simple as that. So that's command manager. So now features tree. So features tree is like it is like a guide of what we have been doing, and that is the place where we can go and edit what we have done. So as you can see here, I have created a plate over here. So on top of that, if I'm creating another circle, I want an extrude. I'm just showing it. I will explain all those things in detail later. So all those things are done here. So features tree basically shows you how the model was made and how you can go back and edit it. So at first the sketch was made, I can go back and edit the sketch if I don't want the sketch of this size. So features gives you all the details of where this particular component, that a particular entity that have used create that component is, and you can go back and edit it. So that is what features tree is. Now next one is property manager. See, property manager is like the area where we input our data. So if I go and select a particular command, it automatically takes me to the property manager. So this is the area where we give our value. So we are selecting what are the features. In features itself, simply we are saying fillet, but in fillet itself we are having multiple features, what particular feature we need, what is the particular value, and how it should be. All these things are explained in the features manager over here, property manager over here. So this is the property manager. Yeah. And in features tree, I missed out something. So we are having different tabs over here in our features tree. We are having a folder called solid models. So these are all customizable. So I don't want to see. So this, if I go to options, you can see there we are having options for the features tree. So here I'm having a model folder for solid bodies. So for example, now the folder is shown. If I have put it shown, then means that it will always be shown even if there is a solid body or not. For demonstration, I'll be showing this here. Currently, I'm not having a solid body, still I am having that folder over there. But if I go and change it in the feature manager to automatic, you can see that it is gone, and once a solid body is created, the folder will come back. So all these options can be set in system options. In our features tree manager, you can set all these things. And breadcrumbs. So we will see this particular stuff. What is breadcrumbs? So when I am clicking on a particular feature, so it will be giving me an history of how it was created and to what all it is related to. You can see that I have selected a face. It belongs to an extrude boss. This extrude boss was created in a sketch, and it is a solid body, and it is a part of this particular part too. If I go and when I go and click the sketch, I'm having the option to edit the sketch, edit the plane of sketch. So I don't have to go back, search in the features tree, where is the particular sketch that made this feature. I can do all these things from here. This is something that comes in handy, and it is very helpful in saving your time while you're designing a real project. Next is task plane. So this is the area called task plane. So here you will be having 3D experience market stuff. Once you log in with your ID, you will be having information over here. So next you have SolidWorks resource monitor. You will be having different stuff over here like property tab builder. So we will be seeing this in detail in the coming modules. So SolidWorks RX is a program that help you capture the problems in SolidWorks in case if you are working with a large assembly and your SolidWorks is slowing down and you want to know what is the reason. So SolidWorks RX is the file that is going to help you. Like that, so many SolidWorks resources are there in this tab. Next is design library. Design library is a collection of standard items like nut, bolts, and I can open you and show you. So you will be having fasteners, different stuff, standard items that are like toolbox. If you go and check the toolbox, you will be having nut bolts and such stuff that are reused in a assembly multiple times that we don't need to create. It is a standard item. For example, an ISO bolt of M8 size, we don't need to create it to put it in an assembly. Such things can be brought up from here, our design library. So we do have an inbuilt file explorer. We don't have to go and search for a particular file. We can search from here. I can go to my files and I can directly select my data from here. So that is file explorer, and this is when we have to, this is viewport. When we have to work with drawings, we will have this. This is a tab that helps in adding appearances, not material, appearances. This is the tab where we will be creating adding our custom properties to our model. Any doubts?
No, I think we're okay.
Yeah. Next is heads up toolbar, heads up view toolbar. So basically heads up view toolbar helps in viewing our model in different ways. So you can zoom into a particular area. You can have a section view. Or here you have this tab where you can align the view. If you press space bar, this will come up and you can align the model in different views. And you can also bring up the viewport as well.
Yeah, this is
By pressing Control and space.
Yeah.
So Control and space.
So sometimes you draw, you know what's the definition of the top, bottom, plane, left and right, and that sort of stuff. So that's where this cube is really handy because it kind of shows your object, and then you just pick the orientation you want to use, and it's a lot easier than trying to pick something on the object itself. So it's really nice. The sectioning in 3D. It's actually useful when you do assemblies and you model part on top of part, you do assemblies and stuff like that, and you want to understand how a certain, section looks like. Because the old method was that you did a drawing, you did a section, and then you check the section on the drawing, right? But now the software allow, the section to be done in 3D as well, which is quite handy because at every point in time you can section your assembly and measure the gaps and stuff, and then readjust and just continue working like that. So that's quite handy as well.
So section view can be better understood here. How the inside of a component will be looking, and this is also very helpful when you are making a rendering of a complex part when you want to explain it to a customer or a colleague how the internal design would be. So next, let's go to mouse operations, and mouse is the most important thing as a designer we will be using. So first we will be seeing the selection using the mouse, how SolidWorks we use selection. So we are having two selections. One is a drag from right to left. So when we drag from right to left, we will be having a green box by default. So whatever it touches will be selected, and we are dragging from left to right. Whatever that is completely enclosed will be selected. So if I'm dragging here, nothing is selected because the box is not completely enclosing anything. But when I'm dragging like this line will be selected because it completely encloses this particular line. So selection.
Familiar with? Is this something that you performed previous software? Same with AutoCAD. Okay, then it's that most of them, most of the softwares now have this. Yeah.
So next thing is mouse gestures. See, if I want to dimension something, I don't want to go here, take the dimension tool and dimension. You can just press.
Can you go back to the definition and what you have to click to get this, because this is something that I think every user would use. Just before you touch the subject of the mouse gestures, can you explain how you can bring that up?
Yeah. So to bring the mouse gestures up, we can press the right click, move your mouse. So it will be showing the mouse gestures that you have set. So this is not, you can define what are the gestures that you need. So when I am doing a 2D sketch, these are the tools that I need immediately. I need a fillet, I need a circle, I need a rectangle, I need a trim command, I need a line, convert entities and dimension.
Yeah. So the dial can be broken from 4 to 12 different sections. I think 12 is probably an overkill because you have to hit the correct angle, But I don't know, maybe 8 is a good idea because you got 0, 90, So we have all the 90s and all the 45s. But if you want to be fast, you do just 4, It's up, down, left, and right. What that means is that the software won't, show a command. It will just execute a command, right? So if you want to do, I don't know, for example, radius, when you do 3D modeling, you just go in and you say, I want this, to, I don't know, right click right, it's going to be radius. And it doesn't even, you just click the edge, go right, and it will just do a radius, So there's no delay in execution of the command, which is quite handy. So when you do repetitive streaming, stuff like that, it's very, very useful.
Yeah.
Because when you do drafting, you're gonna use lines most of the time, and you're gonna use functions like trimming and stuff like that a lot of the time, right? So if you can call those out without going in the menu, it creates a much smoother process. It's a lot easier to operate.
So now I will be showing you how we can customize this. So this I have drawn in sketches. Similar, we do have the command in our features. When you are in features, what are the commands that you need? So here we have set the views and stuff. We can customize this. Go to tools. In tools, we have customize option. We can customize so many things. We can customize our toolbar, shortcuts. We can customize our commands, menu bars. So now we will be seeing how we can customize our mouse gestures. As Mr. Dijan was explaining earlier, we can make it as 2. So if you just want to have 2 commands, you can have 2 commands. That too can be in sidewise as well, and you can have 3 commands. 4 or 8 or 12. So I would suggest 4 or 8 in the beginning, and later once you are well versed in that, you will be able to use 12 as well. So here I don't want this particular command. I want something like extrude or something. I can find the
when you start using 12 commands, I'm gonna pay for lunch.
So we can add select whatever command. So I usually put in my Mouse gestures, I will be using commands like shell, split, and it depends on designer what he uses the most. Combine, extrude, whatever he wants to set up. Like extrude, and some designers what they do, they set up extrude and revolve and roll in the keyboards, and they set up the mouse gestures in more difficult commands like split, combine, and all. So it will be like you don't have to go in the command manager and find any commands. You can work directly using your keyboard and mouse without going and clicking. So it will save it too much of time. So customize. So for example, I want to add some other command here. So I want to insert some command split here. I can just drag it, drop it over here. That will be replaced with split. That is how we can add, customize our mouse gestures. So that's mouse gestures and mouse actions. And now we will be seeing system options. So we have come to this tab several times. You can come to this options, either you will be having a shortkey here if you are using a 2021 or 20 version, or otherwise you can go to tools. In tools you have options. Here we have two categories: system options and document properties. System options is the default setting of your SolidWorks. This is how you want your SolidWorks to be. You can set the color, you can set the stuff like templates, default templates, not a template for a particular document, default templates, file locations, and view, how your features tree should be, how your view should be, where your backup should be, how you're going to input data. All these things can be set. All the SolidWorks, how you want your SolidWorks to open up, can be set up in the system options. These are the properties of the current document that you're working in that can be set in this tab as well. So by that we comes to the end of first module. That was too much of theory. So this is our first module. Let's move to the second module, or you want a 5 minutes break?
I don't know. You want a break or we keep going?
I'll just go to that side.
Yeah, okay, let's
5 minutes,
take.
exactly 5 minutes, Srijit, not yesterday.
Let's take
Yeah,
5
yeah.
minutes.
Okay, was okay. So we'll be coming back in 5 minutes.
No worries.
Yeah.
Yeah, I'll leave the session running. I'm just gonna
Yeah,
mute.
yeah.
How many of you have got this installed on your computers?
I think Jackie only for now, sir. Jackie,
Computers.
Oscar.
Is there?
Hi.
Yeah, we're here.
Oscar.
So we will be moving to our next lesson. Lesson number 2. We will be giving an introduction to sketching. So for all the sketch-based features, the base is the sketch, right?
Yeah.
Yeah. For an extrude, for a revolve, so these are extrude, revolve, sweep, or lock feature. The basic is a sketch. So we will be learning more about sketches in this particular lesson, and we will be learning how to create a new part, how to select where to create a sketch, and how to create it, and all those stuff. Let's see how to create a new part. We will close this one. I don't want to save it for now. So I can open a new file here. Go to File, New. New file will be here. I have to select the template. So templates is a predefined stuff. So earlier when I opened the drawing, you will always see that I open in inches, right?
Yeah.
It is because of the template that I'm selecting. I'm selecting a template with inches. My drawing template is in inches. That's why it is coming up in inches. So I will open a part template. This is one method of opening a new file. And there is another way. We can press Ctrl N. Again, we will be getting the same tab to open a new file. So the location of these templates that we were saying that is opening, right? I'm selecting a particular template, right? Control N. When I press Control N, it is showing me where a template to select, right? It is showing me different templates that I can select from. So this, if I'm not using this, I directly opens means that there is a default template. I'll be showing that the default templates are kept here. These are the default templates. These are the location to the default templates, to the part, assembly, and drawing. You go to the options, system options, default templates. So next is when we open any component, we have, as I have told you, I have opened this particular tab. I opened a new file. This is not saved, not a saved file. If I'm opening a new file, this is not saved anywhere. It is still in your RAM, right?
Yeah.
So I'm adding any data here, so it is still in your RAM. So we have the command called save as, save command. So what we are doing in the save command is like you are saving the particular file and then continuing on the same file. The same file will be opened in the RAM and you will be continuing on that. When you are using the save as command, what is happening? The SolidWorks will be saving this file to your permanent disk, and the old file in the RAM will be closed, then the new one will be opened and we will be working on that. So these are the two commands we are having in save. As for now, we also have other commands as save as, copy disk and all. But as for now, we will be discussing these two commands. And let's go forward and how we will be creating a sketch we can see. So to create a sketch, as we know, as a sketch is a 2D profile, we need a plane. SolidWorks by default provides us 3 planes. So now you can see that planes are hidden here. So in my heads up view bar, I can make that visible. So SolidWorks by initially gives us 3 reference planes in which we can start our sketching in. We'll be having a front plane, we'll be having a top plane, and we'll be having a right plane. So we can start a sketch in different ways. Either you can go to a sketch tab, sketch. So at that time SolidWorks will be asking you where to sketch. You can select one out of the 3 planes that you want and you can start sketching. I would recommend to turn off the planes while sketching. So this is how you can start a sketch. One method is this. And another method is like you can go and click on a sketch on a plane. It can be a plane or a flat. It can be a plane. It can be a flat face of an object that already exists. So I can go click on the plane. I can start a sketch directly from there. I don't need to go to the tab here and select sketch and start a sketch. That is one method. So as I was saying earlier, I can also sketch on an existing face. So I'm having a face here. This is a face which is none of the 3 relative planes that SolidWorks have given us, reference plane SolidWorks have given us. We can sketch on that face as well. So now that face is not aligned and I'm feeling difficulty in making a drawing. So I can press Ctrl 8. That brings that view normal to my sketching plane. So this can also be achieved from here to the normal 2 command. You can go up here, you can find it here. And you can also set up that in your mouse gesture if you want. So I'm already in a sketch. Let's set that sketch. I go to this face. I'm having option to sketch this. Control 8 creates a circle, finishes. So we can do sketch like this as well. Okay. Now when I'm working with a sketch, so for example this sketch, I'm working with this. At the corner I'm having something. This is called conformation corner. I can discard the sketch that I have done or the changes I have done. In this case the changes I have done because this is already saved, or I can accept the changes that I have done. Can finish it. So this is how a sketch is created. So do you have any doubts?
No.
Okay, so we'll go forward. Now we will delete these things, we don't need this. Now we will be seeing certain sketching options. So we have seen how to create a sketch. So in sketch itself, as we have told earlier, that every SolidWorks part is a combination of features. Likewise, every sketch is a combination of sketch entities. What are sketch entities? These are actually sketch entities. What we are having here, we are having a line, we are having a circle, we are having a spline, we are having a rectangle. These are sketch entities. We can make a line by clicking at a point. You can go click at a second point, the line is created. Or there is another method. You can click at a point, drag, drop. So you can use the method that you prefer. So while I'm moving toward this point, you can see that there is something coming up. Some indications are coming up, right?
Yeah.
These are called sketch feedbacks. So I'm getting feedback from SolidWorks. So this is a midpoint. This is an end point. And I also get inference lines. So I already have an existing line. So you see when I'm going to do another line, SolidWorks show me that if I go in this yellow lines means that it is just showing a reference. If you go like this, it will be a perpendicular normal. Or if you select this line, I made another line here. Now when I am going like this, it is showing that it is a perpendicular line. And I'm going down, it is showing that it's a vertical line. This indicates that it's a vertical line. See, when I'm coming here, it is showing in blue because it is capturing an actual dimension. It is giving a snap to this point. So it is blue. So the inference lines can be in yellow and blue, and the yellow lines are the lines that are just giving indications, and blue lines are inferring and capturing an actual point. Is that clear?
Yeah. Yes.
So
Just a second.
yeah.
Start a line without starting here, like somewhere.
You can start wherever, yeah. So in terms of sketching, you're always starting on the coordinate system. Can you just show that you can start wherever you want, really?
Yeah, sure. So it is just a preferred method for when you're starting to learn SolidWorks. The best thing about SolidWorks is that there is no rules. You can do it in the way you want it. But there are certain best practices when you're starting to use the software. You can start anywhere you want.
Yeah.
And it doesn't mean that in SolidWorks the capability is like you don't even need to start in a plane. You can have a 3D sketch as well. You can start anywhere on the 3D point.
So the main, just to explain what the consequence is. So if you have a big assembly and you're introducing a small part, let's assume for a second that when you did that small part, you did it like 100 meters away from the reference, right? Mm-hmm. So when you bring it into the assembly, it will put it, aligned with the coordinate system. Mm-hmm. So if the part is drawn somewhere there, then it's kind of harder to get it, right? So if the agreement is that all the parts that we make are linked to the coordinate system, every time you bring them into the assembly, they will, show in the coordinate system exactly, and then you know where you get them. So it's more, as he said, it's more as a method of, what's best practice rather than a requirement, right? But it's like this happens sometimes when you imagine in automotive or aerospace, they have a coordinate system for the plane or a coordinate system, I don't know, for a boat or a car, right? So when you do small parts, even then it's an individual part, they draw it like it's in the car or it's in the plane. Yeah. So sometimes you're working with models and you look at like, why it's 50 meters away from the coordinate system, right? The reason is that some companies, they essentially push their suppliers to model the part where it's exactly in the product. So when they introduce it, it pops directly in the correct position. It's a matter of practice, like what's generally agreed in the industry, but it's up to us how we want to do it.
So we have seen sketch feedback. So I'm having so I have explained right what we have sketch feedback. So when we are selecting a point, it will be showing that it is concentric, it's a midpoint, and when you are bringing the line or any new tool near an existing tool, the SolidWorks will be giving you a feedback on what you're going to select. So I'm coming here, it is saying that it is the midpoint of the line. So this is called sketch feedback. And so there is another doubt when we are drawing a sketch. I have made a line. I have started a line. How to exit from this command? You can press escape, but some people I have seen that they don't press escape, they will right click and select. And that's another method of escaping from that command. Line is one of the sketch entities that we have. And for line itself, we have center lines and midpoint lines. Center lines are what we use to make the construction geometry. We have circles. In circles itself, we have two methods of creating circle. We can use a center circle. But I would suggest you try these things while you're practicing, then you will be understanding it better. So you're
Yeah,
having 3-point circle because it will be loss of your training time.
yeah,
So this is one thing, and we have rectangles. Just showing, I will be showing you just a demonstration of that too. So we have center rectangle. You make a rectangle from the center. You are having different options. You can make it from a corner as well. Likewise, you are having different entities. For example, you're having hexagons. So hexagons, you can change the size. It's actually not hexagon, it's polygon. So you can give the number of faces and that will change. You can make it 8, 10 or whatever. You can define it as per the circle sizes and stuff, and give an angle. So these are the sketch entities. So as you use these entities, you will be more familiar with that and you will be understanding how it can be used. So for creating a slot, you don't need to make a circle and trim. Now you have having a direct command.
yeah,
You can make it slot directly, and you're having splines as well. There are some commands that are not directly visible, like spline fitting, that you can search out from here. So they are having different sketch entities over here. These are basically used for creating sketches.
Sure.
Yeah. So I have created a sketch now here, right?
yeah,
So when I go down here, it is written it's underdefined. So it is showing the status of the sketch. So there is something called the status of sketch. What is the status of the sketch? Status of the sketch explains what is the current stage of the sketch. In this particular stage, it means that it is not having enough information to manufacture it. I see it in that way. So, or it can be changed, like by pulling at an edge, I can change how the shape and size, all these things. So this is underdefined.
can we touch the subject of what over or under defined is?
Yeah, here. Here you can see, right?
No, but just for people to understand what that actually means.
Yeah. So underdefined means that this sketch can be changed. The dimension and shape of the sketch can be changed by pulling, dragging, or something like this. In a physical sense, if when it comes to a manufacturing industry, it means that you are not providing enough information to manufacture this thing. So if I give something like this length should be this much, and this length should be this much, this is not enough for someone to manufacture this. In the physical sense, that is the meaning, that you are not giving enough information to get this thing created, or it can be changed. So in this two dimension being the same, the shape of the sketch can change in multiple ways, right?
Yeah,
That is underdefined.
yeah. So from a geometrical point of view, underdefined means that if you would drag a point or a line, you would be able to move it because it's geometrically not defined, right? But from a manufacturing point of view, it could also mean that you're not giving enough dimensions to people to actually understand how to do, right? That's as rigid as you want, right? Because in some cases, when you do modeling, you maybe don't want to put all the dimensions on because you don't want to constrain everything because it's not important to you. For example, you have a certain type of shape and you know what you've done is good enough. You don't have to put another 5 dimensions on because it doesn't mean anything to you. So you can kind of do a 3D and progress with that. Nothing will change that shape later on because as soon as you go out of the sketch, you lock it and that's it. So all the changes and all the features you introduce after, they can't change what you've done before. So even if you would draw something without a single dimension, you can still extrude it and apply all the features on top of it. But clearly, you want to make sure that you have enough dimensions on to reproduce that shape. And when you put dimensions in the sketch, we'll see later on, you can show them in the drawing automatically. So it makes sense that the sketch is defined a certain way, because then it can appear on the drawing a certain way, right? So if you put those dimensions the way you think people would need it to reproduce that part, in a certain manufacturing process, that's exactly what's going to show on the drawing.
Yeah. Hello. Hello. Hello.
Yeah, we're here.
Yeah. So now this is a fully defined sketch. For a fully defined sketch, even if I pull or move, the dimensions won't be changing. So sometimes while designing, there is a chance, like if you're not that experienced in SolidWorks, like if you're making a complex shape or something like a freeform or something, you are having some dimensions that should be fixed and some can be moving, like sometimes in plastic designs, bottle designs, when you come up, there will be some dimensions that you don't want to change. So you'll be defining that dimensions and you will be leaving the freeforms, as Mr. Dejan was saying. So it all depends on your method of working. So in the beginning stage, if you can make the sketch constraint, it is good. If you are confident that this is good enough, you can go further. That is also a good practice. But I understand the basic concept, right?
Yeah.
So now it is fully constrained and this can't be moved. So we will be next going to see what is an over-defined sketch. So it is a fully defined sketch and I want to add some other dimension here. It is a it's an over-defined sketch. So I'm having an extra dimension which is not required to define this. So this scenario comes up when you're physically measuring something. You have taken 2 dimensions, or for example, you have got this physical component with you and you are supposed to design it, and you have measured this using a vernier caliper. You have measured all this dimension, but this dimension is not matching. You are entering 2 different values. It means that there is a mistake in some value you have measured. So I see that in that way. So if you are having a conflict over here, that means that there is some difference in the measurements that you have taken. So this is an over-defined sketch. So these are the 3 stages of the sketch. One is completely defined, fully defined sketch. Second is underdefined, and third is over-defined sketch. This is an over-defined sketch. So that are the different stages of a sketch. So when you are having this error, like an over-defined, or you're having some under-defined sketch, or you're having an opening in a sketch, for all these things we are having the sketch expert and sketch checking options in SolidWorks that can help you in resolving the issues that we will be learning in the coming modules. So let's continue with the. So these are some examples of how the sketches should be and how a sketch should not be. So if you are going to make a feature, you are going to make a solid feature, it is always recommended to have a completely closed sketch with single profile, which is defined, but not always, but it depends on the nature of work that you are doing. You can have sketches with multiple contours, like for example, if you want a plate with a hole, that is also good. You can do that. You can have an open sketch as well. This is also an acceptable way of sketching for once you're experienced in SolidWorks, you can use that methods as well. For example, if I'm having an open sketch, I am having an open sketch here. I can still extrude it, but with a thickness feature. Thickness feature means that it will be adding a thickness to the particular profile that I have given. I have the capability of reversing the directions as well for that. So we can even use an open profile for sketching. But this sort of profiles are not acceptable, where there is an intersection, where it will be creating a self-intersecting body. This and this are not recommended, or this is not possible to create a solid body in SolidWorks with self-intersecting sketches.
Yeah.
So these are called self-intersecting sketches, and this, we will not be able to create a profile. We will not be able to create a feature with such sort of sketches. Yeah, you can select a particular contour out of this and do it, but it is not a preferred method.
Yeah.
That can also lead you into troubles in the later stages of modeling. We can have independent sketches in same independent entities in different independent closed entities in same sketch to have multiple bodies. But
Yeah.
this is also recommended once you are expertised in SolidWorks.
Mm. So all the lines we create in sketching, you have two types of lines, two types of features if you want. Because sometimes when you sketch, you want to have some reference lines, and you can have those. You can just click on the line and call it construction geometry. So when you are on the sketch, can you show that maybe?
Yeah, sure.
Just, because when we do a sketch and we want an object extruded, that's not necessarily, the only lines we have in the sketching, module. You can do a lot more in terms of, if you want to, I don't know, create a certain feature in the middle of or in a certain position on an object, you can use the outline as a reference. You can dimension to it, or you can make a line that's gonna act like a reference line. So you can just make a line and then convert it to a reference line, just to show how that works. No, it's
So this line what we have created, they are created using a center line or a construction line. So if I'm trying to extrude this particular line won't be considered.
Just go back to the sketcher and just create a line somewhere else and convert it to a reference line so that it doesn't have any influence on the extrusion.
Yeah. So you can see I'm having a line over here.
Yeah, just whatever, doesn't matter.
Yeah.
Yeah.
I'm having a reference line over here.
Yeah.
So this line for.
And now we can convert that one into. Yeah, just convert it into a reference. It's not gonna affect.
Right click here and I can convert it into a reference geometry. And I just want to,
Yeah, we just click it and we say it's a construction geometry, and then it doesn't affect your module. It's kind of like whatever you see shaded now is gonna be extruded in space, but the line is there for you to support, the sketch. So we can have lines, circles, all sorts of objects. You just convert them into construction geometry.
I can have a circle over here. I can also have a circle over here.
Yeah.
I can convert it into.
That's quite handy, It's if you leave it like that, it's gonna be an object. If you convert it, it's gonna be a support object. So it's gonna be a reference geometry. There are cases when this is, it's quite important and quite handy.
See, I'm having a circle over here. There will be conditions like this, where it is tangent to this circle, and I want this line and this line, but they are not required in the actual model I need, but it is reference geometries. So still when I extrude, my sketch is not affected by the construction geometries. See, so only the lines that are construction geometries are ignored. If you're having any other lines or points, it will be creating issues. But construction geometries are very handy in when we have too much references to which we have to link the model to.
Now go back into it. See, you just click the object you want to use.
So that's clear?
Yeah, it's gonna be, you know, a routine when they start using it, but
Yeah.
just know what the capability is.
Yeah.
So when you do a brand new object, you are doing it on a you know white canvas, right? But when you do an object in assembly that links to other objects, you can reuse all the features of a part next to it in your sketcher, right? So when you sketch and you have a part underneath, you can connect lines, dimensions, and everything to the part underneath. So it's really a lot easier, you know, when you can consume all of that information in the sketch.
So it depends on industries as well. What's how you are going to work on and what is the sort of work you are going to do.
Yeah, but
You are,
that's one of the tasks that we have to do. We have to sit down and agree on the way we want to do it.
yeah. So that's it. So now this is what we are having here. So I have
Yeah,
told you earlier, right? SolidWorks automatically applies some relations. So it might have applied some relations that I am not able to see that relations. And I have applied a tangent over here, tangent circle I have created. So I want to see what are the relations in this case. Because sometimes what happens, these relations can cause errors. Some relations can cause issues.
yeah,
So I'm having a So I want to see all the relations in this particular sketch I have created. So it can be seen by in our toolbar here. You go here. So view sketch relations. You will be able to see all the relations in this sketch. So we are having two tangents with these two lines. We are having horizontal, vertical constraints, and this sketch is an underdefined sketch. You can see here I'm having a blue strands over here, so it's an underdefined sketch because there some dimension is missing. So this is how we can hide and show relations. Okay, so in case I want to see all the relations, there is another way: display and delete relations. You go and see here, it will be showing all the relations. So we have a filter over here in which we can see what are the relations inside a sketch. And if I just want to see the relations to a particular entity like this line, I just want to see what are related to this line. For example, I want to move this line a little bit. So I'm not able to move this line, right? I want to move this to 20 mm to this side or 20 mm to this side. I'm not able to move this. I want to make this line free. So these are the relations that hold it together. So if I delete those relations, I can see in this what relation is holding it there. So this particular one, this is holding it in this point. I can remove that relation. Again, I'm free. I can move the sketch. But while moving the sketch, make sure that you are not dangling it.
yeah.
So my entire geometry is damaged. So this is a use of, like if I'm having defined this thing, I'm moving it, and if I am defining this thing, a dimension from the center point, so this can be changed. But if this relation was existing there, I was not able to do that. I will make it, I will say it once more. So I want to make a change to a existing sketch with lots of relations. I'm not able to change the relations because of this particular constraint. I want to remove it. Either I can directly go click on it, delete it, or I want to remove constraints applied to a definite sketch or a particular entity. I can see and delete them by selecting that one. So here it is having a constraint of horizontal. I don't want it horizontal. I want it to be in a degree. So if I want to give it a degree over here, if I try it here, it is coming 90 degree. I want to make it something like change it to other than 90. It is not possible because I'm having a horizontal constraint over here. So I can go display relation. So this or this is dangling. It's overdefined. This area it is overdefined. If I remove this horizontal, if I remove this horizontal relation over here, yeah, so again I am having other constraints over here. That's why it is not letting me move this particular component. Okay, length is there. So I'm having some problems in moving a particular constraint or moving this, I don't be able to understand what is stopping me from moving that. So I'm giving it a horizontal constraint here. So I want to move it in an angle that like I have moved it earlier. I'm not able to do that. So in that scenario, if I want to do that, I can go to display relations. I can select that particular component. I can see what is stopping it from moving that. I can see that relation. I can remove it from here, click it OK, and move it in any angle that I want. So hope you understand the use of show and display and delete relations, right?
Kaya, gagawin mo na. Oh, pero kulang pa din yun, di ba? Wala naman din.
So, hello?
Yes.
Yeah, ma'am. So can we continue?
Yeah.
Yeah. So it will be better if I'm getting some responses. So let's go to relations. So so you understand what I explained right here. What is the use of removing a constraint that is already applied? Is it clear?
Yes.
Yeah. Okay. So let's go to our next section. How we can apply relations between two existing entities. I'll remove this. So we will be starting with the relation coincident. So we are having 2 points over here. I want this line to lie on this particular point. So in that scenario, we will be using the constraint coincident. So how to apply that constraint? We can click on one point, click what we need to be coincident, make it coincident. So this line is coincident. Okay, so this line lies on this point. So that's the coincident command. So we can move to the next command. So we will be moving to the next command, merge. I'm having 2 points. I select these 2 points. I can merge them. Select the first point. Select the second and merge. And we are having a third constraint over here, parallel. Third relation. So I can apply the relation manually, or I can just draw the line indicating to the line. So the constraint will be automatically applied. Or I can make a line which is not parallel to it. Press the line, press shift key, press the next key, then it becomes parallel. So even if I'm changing the angle of that line with respect to the horizontal line, if I'm making it 145, the line that is parallel to it will automatically readjust to that. Is that clear?
Yes.
Yes.
Yeah. So we will go to the next command, collinear. So I'm having another line drawn here. So if I want to make these two lines collinear, it will align itself to the earlier created line. If I'm moving this, it will be adjusting with each other. So it moves in any way the SolidWorks pleases unless I have defined one. So if I am defining this point at once, then there is only little amount of way this line can change. It can only change in length. All other movements are now constrained. So, and our next point is perpendicular. I got a point line. By drawing itself, I'm getting that constraint over there. I don't want that. I have made a line which is not perpendicular. But now I'm making this perpendicular to this line. So it automatically adjusts the other line. So that's how we apply parallel relations. And we can go and see vertical. So vertical is basically when you are drawing a line. If you are drawing it vertically, it will be automatically assigned. Even if you have drawn a line little bit bend, you can make it straight by applying vertical. Or you are having two lines. Then make it vertical. Okay. And equal. So equal is again, I can say this and this are equal in length. So it will be 60. So our next command is midpoint. So we can say that this point and this line, this is the midpoint. Midpoint. So that point will be becoming the midpoint of that line. So this will all be used. It is not like we have to use it all the time. It depends on the sketch you are working with. To define the sketch, not only by using your dimensions, you can also define the sketch by using your relations, which will reduce the number of dimensions in a drawing, and that will make your sketch a little more simpler, and it will be easy to use to create a 3D model. That's why we are having relations. So, and we are having a circle. We need a circle that is tangent to these two lines. Tangent. Tangent. So these two lines are tangent to each other. So that's how we can add tangent command. Press the first entity, press shift key, select the second entity. You can add the command. And all the commands can also be added in another way. Go here, add relationship, select the components to which you want to add relationship. For example, I'm not having this circle here, then having another circle, we can go here, add relation, you can select the arc, select the second entity to which you need relationship, add tangent, the tangent relationship is added. So this is another method. Yeah. So, like, everything is clear up to this?
Yeah.
When you wanna move the object, you can turn around and that's why this is the command. What you can do is that when you push the center button, the middle button, to do the rotation, you can push control, do pending, you can push shift, do continue.
Now what happens is if I want to sketch
So now we are going to dimensions. So we are having different dimensioning methods in SolidWorks. We can use different dimensioning methods. So we are having smart dimension. This is the most commonly used one. So we can use smart dimension to dimension any geometry. It will be intelligently capturing according to the shape of that geometry and what sort of geometry it is. So I have selected an arc, it have identified it as arc, and it have taken the radius there. It's taking a vertical line, it will identify it as a length, and it will be taking it as a length. And if I'm dragging a line, it can give me the vertical length of that line.
The icon, the cursor, that's where you want.
It can also give me the horizontal length as well.
Yeah, but you can move different points.
That's how the smart dimension works. So there are other dimensioning options. We are having horizontal dimensioning. Horizontal dimensioning is when we can only do horizontal dimensioning with this tool. So if I am trying to do a vertical dimensioning, the smart tool is activated. Horizontal dimensioning tool, I can only do horizontal dimensioning. So this is horizontal dimensioning tool, and we are having vertical dimensioning tool, which is similar, but it does the dimensioning in the vertical side.
You can sketch also on software and all this.
So we'll be doing vertical dimensioning using the vertical dimensioning tool. But most of the cases for a simple geometry like this, we will not be using vertical and horizontal tool. We will be using smart dimension. And the one tool that will be useful in case of such kind of geometries is ordinate dimensioning. So we can have horizontal ordinate dimensioning. That means that you can dimension from a reference point.
So what we can do is establish on that one.
Yeah. So this first line will be considered as 0, and the rest of the dimensions will be calculated from there. Double click the same point again, so I get the same value again. It's over defining, so it's giving me an error. Coordinate dimensioning 0, second point, third, fourth, and fifth. And the good thing is that we can align all together, and the gap will be automatically maintained. So this is ordinate dimensioning horizontally. The same is ordinate dimensioning vertically. So that's it about dimensioning. So is the dimensioning part clear? Do we have any doubts in the dimensioning part?
No.
So we have something called modify tool. So see all this dimensioning and all, when you're working with your real scenarios, when you're using it, you'll become having doubts. So try to practice to try to use these tools and you'll have doubts on that. So we are having a modify tool with all our dimensions. So if you click on it, you double click on a dimension, you will be getting an option to modify that. So we can rename the dimension. Renaming the dimension is useful when you are using a design table for creating multiple configuration of the same component. So if you are so if you're creating multiple configuration of the same component using a design table, at that time we have to give the changing dimension to indicate that properly in the design table. We may need to change the name of the dimension, so we are having an option here to change the name of the dimension. There are different scenarios where we need to change the name of the dimension. We can give it as R1. This is the area where you can input your value. You can give it 155. This is to press OK button. If you press this, the modify dialog box will be closed. This is the cancel button. It will discard the change and it will close it. So this is the rebuild button. When you press the rebuild button, the dimension will be automatically updated without closing this. This is the tab that we can use to, so see, if you see here, if I rotate my central mouse button, the value is increasing. So how much it should increase with each rotation is determined here. Okay, I give it 3, and if I rotate it, and then it will be increasing by 3. This is an important tool that you can use when you're doing some conceptual design or for adjusting things. And this is something that marks the dimension as important. So you will see it later in the today's third module, what is important dimension. So if, by default, all the dimensions that we are creating manually are marked as important, and these are brought into the drawing when you're calling for the drawing. When you bring the dimensions from the 3D model into the drawing, these are the dimensions that comes in, which are marked as important. Some dimensions we can remove the important mark if you feel like that is not important to be shown in the drawing. So that's modify tool, and we'll see an introduction. We have already seen the extrude feature. So this is the second module. So this is the extrude feature. We have used the cross sketch to make an extrude. So we will be going in detail about extrude in the next module. Do you have any doubts?
No, so far, okay.
Okay. Okay, Mr. Dejan, we will move directly to the third module, or would you like to take a break?
Yeah, we can go and then we'll have in the middle somewhere we'll have another break. We can have a break one.
So by 11 we will be back, or?
No, what I'm saying is just keep going, and then when people think they need a break,
Yeah. Okay, great. So let's go to the third module. Before that, there are certain guidelines of sketching. This is all what we have discussed till now. It's a collection of things, like to make a sketch so that we don't get any errors while we are doing the extrusion or something. The basic rule is like keep the sketch simple. Like simple means reduce the number of dimensions that you are having in the sketch. Like for example, if you are having two equal lines, make the relation that they are equal and reduce the number of dimensions that you have, because it will be helpful when you are taking it to the drawing as well. So that is one thing. And make use of your origin. So make use of your origin. This is not mandatory. This is something that can help you when you're taking your model in the further stages. It will be helpful in aligning, will be helpful in placing it in a proper place in the drawing and all. So when you are making a sketch, you have to decide, you will learn in the next topic When you're making a sketch, make sure that you're making the sketch of the most important profile first, then make the feature, and next then make the next feature. Like you can see that in detail in the next module. So these are the basic things. So as designers, you will be knowing all these things while how to make a sketch and all, right? Do we need to spend time on this?
Yeah.
Yeah. So these are the basic considerations while making a sketch. So we can move out to our third module. It will be little more of practical.
Yeah, I think we can start with that and then take a short
Yeah.
break. Then we'll continue.
Yeah. So we will be going to the third module. So in this module, in the third module, we will be learning how to make a part. Basically, how to make a part. What are the considerations that should we take before making a part? Second, when we'll be learning little bit more about the extrude command. Then we will be learning about hole wizard. Then we will be learning about fillet little bit in detail. Then we will be learning how a sketch can be edited after we have created it, and we will be learning how a feature can be edited after it is created, and we will be learning rollback feature, and we will be also learning how to apply appearance to a particular model after it is made. Then we will be learning how we can take it to the drawing view and how to create a drawing, how to automatically dimension that, and little bit of detailing. That is all this module about. Let's start. Okay.
Yeah.
So basically, while creating, there is the first consideration that we should have while creating a part is like, I want to create this particular part. So as I have explained, we will go new part. Okay. We will be selecting the plane. First important consideration is what is the important profile in this part. So what will be the major part on which we can build rest of the parts in. So for this particular component, the important profile will be this rectangle, right? The bottom rectangle.
Yeah.
So we will be creating. Then we have to identify in which view do we need that. So if you are placing it in a drawing sheet, in which view do you want that rectangle to be in? That is another consideration. So I think that will be most good in the top view. So how we will start the sketch? First we will be making this rectangle. We'll be selecting the top view, rectangle, and rectangle we will be selecting the corner rectangle. I will be using the origin for reference. So there's a dimension there, 4120. So you might have seen that I have just drawn a rectangle and I haven't given any dimension at first. For the first sketch, we can just make a profile and the sketch will automatically adjust to the scale of the first dimension being given. So that's the feature in SolidWorks. So we have created our first sketch. So now another next step is to extrude this. So how we are going to extrude this? So we have created the sketch. We go to the conformation corner, accept the changes in the sketch, extrude. I'll be extruding it at 10 mm. So when I'm extruding it, I'm having certain set of commands over here in the extrude tab. We will be going in detail about that. So I accept it. I just want to show my sketch. See, my sketch is here. From my sketch itself, it have extruded 10 mm. So we are having a scenario. I don't want to make it extrude from the sketch that I have created. I want to offset it a particular value, like from the sketch, from the plane where I have created the sketch. I want my extrude to be something like offset, like for example, a 10 mm. I have an option for that. I can also have an extrude from a particular surface. For example, I'm creating a sketch here. I made a hole over here, and I want this projection, this boss to be 20 mm from this face. So I don't want to measure this value and all, for in case if I don't know this value. Again, I can go to features. I have an option, surface, play, face or plane. I can select that, this face and the direction. I can reverse the direction. How much is the extrude value? 10 mm. So we are having an option here whether to merge it or not. So if I am already having an existing solid body, if I click merge, it will convert into a single body. If I am removing that, if I change to wireframe view, I can see that they are two different components.
Yeah.
So, and again,
That's
we
an
are having,
important part, that's linked to this. So one part can include more bodies than one. And when you do when you extrude the parts in space, you can dictate to the software whether you want or not to merge the bodies. Where is that useful is that sometimes you can use Boolean function as well, which means, add, intersect, remove, and that sort of stuff. So you can create multiple bodies and then play with those, and you could to achieve a certain result, because sometimes it may be easier to have a secondary body that intersects your body to get the result you want, right? I think what would be interesting to see if you can create like a wavy surface on top of this object, and then create an extrusion that goes to that wavy object, and you can show the offset and what happens, because I think that's quite an interesting example, so they can see the functionality of the extrude, when you do it against an object.
Yeah, sure. So for example, before doing this extrude, different plane, so it don't come straight to my view, so I have made it straight. So
Yeah, just make a spline on top of it.
yeah, so I am having a spline over here. Features, I'm having an extruded spline, so I'm having a curved surface. Want it in the opposite direction.
Yeah.
I would have just reversed the surface there, but I just did it like this. Now
Okay, that's okay. Just
now here the end condition. When I come to the end condition here, I can select it up to surface, and I can select a surface. See?
Or you can say you want to offset from the surface. That's also an option you got available, right? So.
Yeah. So I can offset from the surface. The offset from the surface, if I'm keeping 1 mm, you can see here at the side view, I'll show you. It is exactly offsetted from that surface 1 mm. So I can reverse the direction as well. I want 1 mm more from that surface. I can reverse the direction, so it is 1 mm more from that surface. So this can also be achieved in these tabs. Now again, we are having that merge option, whether you want to merge the solid bodies. So these are the end condition options. You can also select up to a body. If you are having another body here, we can extend up to that body. So we're having mid-plane option as well. Mid-plane means that the value that I'm giving will be equally distributed from the point where it is being extruded. And this is a very interesting option. From surface.
Well, I think
surface
the previous one it's probably more interesting for our job, because we have a lot of statues and all sorts of objects that are used for image and for, and for kind of like for more or less some statues that we do in sheet metal, in aluminum and stuff. So when you do a cladding, for example, that looks like a letter or something that's even bigger, and you make a fascia, that has to meet that cladding, you can simply cut it with that surface, or you extrude up to that surface. So it's a very easy process to do, and it's really, seamless, So once you have a reference, all your objects can have a reference. You can cut your beams on that surface, Can you, for the sake of trying, I'm not sure it's gonna work here, but does the trimming function work on a part level? So if you would need to trim that body with that surface,
Yes,
I think
sure, we can do that. We can do that. So I was showing you now split.
yeah,
We are having a command called split.
yeah,
Showing you that. So I'm having this surface. I want to cut this body. So I can keep this body or I can consume this body. Consume means that it will be removed. If I keep it, it will be kept as another slice. For now, we will consume that body.
yeah,
So it is cut using that surface.
yeah.
If I'm
Or
using,
for example, if you need the sheet metal cut, you can consume the other object. You can trim the other way. This works on assembly level, on a part level. It works on all possible things. And this is where the functionality of these softwares is really important because everything is mathematically defined. It understands where the volume is and where the volume isn't, right? So when you cut, trim, and do all sorts of other operations in this kind of softwares, this is like, a very fast, seamless process compared to, something else.
so I have cut that surface by using direct offset command. I have moved, I have cut it, I have made it a little bigger. I can do
Yeah,
alterations like this using move. SolidWorks is a very flexible software. So
yeah,
now I have cut that particular top part. So I have split it. I just want to make it something like an umbrella. I just want to make that face an offset something. And this
yeah,
is also defined. So I know
yeah,
that this is exactly 10 mm. I can go
yeah,
back and change it if I want. I can make it 1 mm. I can make it something like 0.5.
yeah.
As I please, I can change all these things. So these are the functionalities that we are having. So we are discussing about extrude command.
Yeah. Yeah, I mean the reason
Yeah,
I'm asking this is because we make a lot of shapes that
yeah,
are boxes and stuff that
yeah,
organic shape, more or less free
okay.
shape.
Yeah,
And it's just to show what the capability
yeah,
of even a single
exactly.
function that extrude is, when you compare it to a
Yeah.
curved surface, a funky organic shape surface.
So you're having surface training as well, right? In surface, we will be covering in detail how surfaces can be used to create a very interesting shapes. So for making mostly while working with organic shapes, we will be working with surface tab. In solid also, we are having a huge number of options to create such shapes, like what Mr. Dejan have mentioned now. Extrude up to a point and cutting and all this. We have lots of options in SolidWorks. So we have introduced to extrusion and the different commands available in extrude. So we are come up to end condition. Then we are having another option to give an angle. So this option is basically used mostly in industries like casting and injection molding and all. Sometimes where you need a draft for the component to come out and all, you can give an angle of 5 degree or 10 degree. From the sketch angle, you can make it inside or outward. This is another functionality that you can operate directly from inside SolidWorks, and you can make the direction. If you want a different length to be extruded to the other direction, you can do that as well, and you can have a different angle for that. And you can also have contours. You can have another sketch inside this, and you can select a particular area that you want to extrude. For example, in my sketch over here, if I'm having a circle inside, not only circle, I can have whatever shape inside lies. Like I'll be showing you, I want something like this. I made something like this. So this is a sort of sketch I have told not to make. So software will be saying that this is not possible to extrude because we are not having a closed profile, but SolidWorks you can extrude that as well. I can select the sketch and I can select the contour that I want.
Yeah.
I can extrude this up to a point. I can extrude this as well, separate.
Or just
So
a single line. Yeah.
So this is an extrude functionality. In extrude we can have in the same sketch I can have different contours. So again I am going for the extrude. I'll select the same sketch, but I will select a different contour this time. It automatically merged as the merge option was clicked in, selected in, so it automatically merged to make a single entity. So that is contour option in this. Okay. So that's our extrude functionality.
Yeah.
Now let's get back to our model. So we were working on our model here. So we have created our rectangle and we have seen different functionalities of our extrude command and how extrude different options in extrude command can be used. Well, till now we have been using the planes provided by SolidWorks to create the particular geometry. Now I don't want to use the SolidWorks because the nest profile, as you have seen, if I have shown you earlier, no, we can press Control and Spacebar and have the view. We can have the 3D view, isometric view, and however I want to look into this particular product. So this is how it is there in the model. So I just kept it like that, and I can hide the sketch here. Once you create a feature, the sketch will be already automatically hidden, but I have made it visible that it was showing up. So now I want to make a sketch in this space. I don't want to have a plane there. I can directly go make the sketch. Now we will be seeing another functionality of our line command. So I can take a line, go up, click, go little ahead, come back, and if I move, it will become an arc. If I go again straight, it will be a line. So a shape can be created without taking back and selecting a arc. You can create the arc like this easily. Then I will dimension it. This dimension is 50. $35. So I have just made a free sketch and I have dimensioned it and I have completely defined this. So it is no requirement for us to make the sketch completely defined at first. You can just make a free sketch that is approximately of the same shape. If it is near to the real value, it is, yeah.
Can you once again? Can you delete it and do it once again?
Yeah, for sure, for sure.
Can you do it on another surface on the perpendicular side?
Yeah, sure, sure. You want to do it here? Tell
Yes.
me where you in this
Okay.
slide.
That's
This face you want, right?
yes.
Okay. I select this face. So I want to make sketch in this face. I'll move around. I will see like this. I select this face. I click on that face. Then I will be getting this short menu over here. So it asks me what I need to do. I am having different options. I can even edit the previous feature. I can edit the sketch, but I will make a new sketch. Okay. Plus sketch. So it is not automatically aligned to normal to the screen. So I'll press Control 8. Now it is aligned. There is another option to do that. You can go here and press this, and you can also keep it here as well as a shortcut. If you want, you can keep it outside as well. So now view is aligned. I take a line, I bring the line, I click a point, I take it outside, I bring it back to the old point. When I bring it back to the old point, it becomes an arc. Then if I go ahead straight, it becomes a line again. And then I have given the dimensions. Like whatever dimension was from that side, it was done. Is that clear?
Yeah.
So we will make our sketch again. So I have shown you, like, I don't have to go and there and take the line and all. There is an easy method to do that. I can go here, I can select the line. When you're doing the design fast, you can do it in this way. You don't have to move anywhere. You can draw the lines here. That's done. I move up. I'll take the dimension tool. I go here. I give the dimension 50. I take the point, give the dimension here 35. And I give the dimension here 20. Now sketch is done. So most of the cases, so you will be also having, now I exit the sketch. If you have set the extrude in this, you don't have to go there and select the extrude, right?
Yes.
In the mouse gestures, you can set extrude or whatever command you want. So extrude is having, you can select the extrude, the opposite direction, so give it 10 mm. So these two features are created, right?
Yeah.
Now I want to create, we will be introducing as to a new command, hold wizard. So this is something that is mainly used when you're working with assemblies or mainly engineering components. You will be using this command. This will be helping you to create standard holes with in different standards. You are having ISO, you are having this, you are having DIN, you are having GIS or whatever standards you want. All the standard hole size can be created without creating any sketch. You can directly create the hole from here itself. So I want to create a hole for, say, I want to create a hole at the center of this arc in this face, an M8 hole, a counter bore I want to create. So I don't want to create any sketch, I don't want to select any plane, I can directly go to the hole wizard. So it will be asking me what is that you want to create. So I want to create a counter bore. I'll be selecting NC metric and volt, and I want something like M8, and it will be asking me what are the position. I'll select this face, hover it over the arc, then it will show me the center point, and that's it. My hole is created, and this can be called back in the drawing without saying that is M8 and all. When I directly call the hole call out, it directly comes out and gives all the dimensions. So the hole is created. Now we will be seeing another option. So here we are having different hole types. If you are familiar with the hole types, so we are having normal holes, we are having holes where we can make double holes, drill sizes, for holes for tapping, we can do it here. We can put holes for putting water connections and stuff we have here. British standard thread, pipe threads are there. Everything is here. You just need to know what you want to make and select the particular standard that you want to make. Select the sketch, select the face you where you want it, and you can also dimension it from the hole wizard itself, and we will be showing that in this module itself. Okay, so we have created the component. Now I want to add a feature. We want to add a added feature, applied feature, that is fillet. So we are going to apply fillet over here. So everybody will be familiar with the fillet command, right?
Yeah.
Yeah. So in SolidWorks, we are having different type of fillet commands. Like we are basically having 4 fillet commands. One is a normal fillet, constant fillet. Like if I'm applying an 8 mm fillet, it will be, if I select this to it from this edge, if I'm selecting, it will be an 8 mm. From here to here, it will be an 8 mm. I can also have a variable fillet. That means that the fillet will vary from one edge to the other edge. So here I can make it a 2 mm, and here I can make it 8 mm or 10 mm. I can make face fillets, that is, I can select two faces and I can make a fillet, and I can make a round of fillet as well. I will be demonstrating each one. So we will be adding a constant fillet now, 8 mm fillet. So this is an 8 mm fillet that I have added. So, and I want to add a face fillet. I'm just deleting this just to demonstrate the face fillet option. So once I have used the fillet option now, I don't want to go up and here and search the fillet option. I can find it here in the recently used items. Fillet, hole wizard, extrude cut, whatever I have recently used, I will be having it here. So no need for going up here and selecting the command again. You can select it from here. Fillet command. I will show this now after I complete this three. So I'll be using face fillet. I can select two faces. I can apply a fillet between them. Sometimes we need face fillets, so face fillets can be applied. And we can also use a completely round fillet. So it will be making a complete round of that face. Now let's try to make a variable fillet. I'm turning off tangent propagation over here. I'll explain what is tangent propagation. So I'll be making a variable fillet in this edge. Here I am making it a value of 3, and here I am giving a value of 8. See, this is a variable fillet. So this will be useful if you're working with organic shapes, and all variable fillets will be coming in handy for you.
On AutoCAD? This function is not there on AutoCAD. Any other features you have?
Can do loaf something. Yeah, but it will take time.
Okay. Okay, proceed, Srijay.
Yeah. So we are having a variable fillet over here. So let's go back to our fillets tab and explain what is tangent propagation. So tangent propagation is like, if I'm keeping this option on, it will be propagating the fillet over to all the tangent faces. That is tangent propagation. I can have a full preview as well as a partial preview. So if I'm having a full preview, if I'm selecting this particular edge and the next edge, it will be showing me a preview in each edge. But if I'm having a partial preview, it will be showing preview only in one edge, and rest will be applied, but it will not be showing a preview. We can also have no preview option as well. That symmetric and asymmetric fillets will be better. We will be covered in the advanced modeling sections, the training sections. So we will be applying 8 mm fillets on this edge, but for now I'll be keeping it in full preview to have a look how it is coming. So I have applied fillets over here. Oh, it's too big, so we will apply a 3 mm fillet. So if I see my model over here, it is not how it is. It propagates completely, right? So I have already created this. So we can go back to that as well. Now I wanted to, before creating, I forgot to make a sketch here. I wanted to make an extrude cut, right? And my extrude cut was before I make the fillets. So in this scenario, what can I do? I can roll back. I can make the sketch here. So we can see the dimension of that sketch over here. It's a 3 mm sketch cut over there. So I started the sketch, but it is not aligned, so we know what to do. We plus Control 8 and make it normal to our view. Make the sketch. Smart dimension it 3 mm. And we give an extrude cut. Okay, I have given an extrude cut here. So we can see some commands in extrude cut. It will be same as our extrude feature, but one extra option that we are having here, instead of merge, is we can flip direction. So what will we do when we flip it? So when you flip it, your outcome will be like this. You understood what happened, right? It selected the common area. Rest was removed. If you remove that, we'll be having this cut. So I have added nest fillet. So now I remember. So I wanted this fillet here as well, right? I can edit a feature after it is created. I can add fillets to that. I can add commands to that. And I also remember that, okay, this need to be traveling all over this. The fillet need to be propagating all over here. It is not propagating. So I will go back. I will edit that as well. I wanted to add it this. I selected one edge and it automatically identified the tangent propagate and it propagated. So see, we have gone back, edited, added a sketch in between the features that we have already created, and we have added edges to a fillet. We have edited a feature, and again, so it is not again like the model that I'm having here. In the model that I'm having here, the cut is same as length as this edges. So I want to go back and edit that sketch. That is also easy. You can go back, edit that sketch. While editing that sketch, select the line. We are not going to give any dimension. I select it, I say it is collinear. I select the second edge, I say it is collinear. I don't need to do anything, the model updates automatically and it's done. So now I want to again something else. We are having two holes here. So we are having two holes over here, and for that holes I'm having a dimension. So I'm having two 7 mm drill holes over here in this face. But the dimension of the holes is given from the edges. So I don't want to do that fillet now. Before the fillet, I wanted to add that holes. So what I will do, I will roll back. This is the future roll back. I rolled it back. I went to the hole wizard. This time I want to add just drill holes. I will select the drill size. I will make the drill size 7. There are so many drill sizes, so I'll make it 7. I want to select the position. I select this face. I place it one here and I place one here. Now I want to dimension this. Again, I don't want any sketch or anything. I will go cast the smart dimension. I'll say that it is 15 mm from the edge and it is 10 mm from this edge. Again, I will go here. I'll select 15 from this edge and 10 mm from this edge. So that's it. I want the holes. So holes are created. After the holes are created, yeah.
Sergio, did you show different options for holes in terms of what the capability of the software is for, I don't know,
Yeah.
countersunk, reward, this and that?
Yeah, so in whole wizard, basically what whole wizard does is like it simplifies the process of creating different types of holes. You can have a counter bore, you can have a threaded hole, you can have a piping hole, you can have different sort of holes that you can select from this different options here. So for example, you need to have a counter bore. So we are having counter bore here, you're having straight tab here, you're having tapered tab here. So you need to know what sort of hole you need to create. Okay. Are you following? Are you able to understand what I'm saying, or shall I show you
Yeah.
another?
Yeah.
So I can select.
One thing that I would like to mention, which is, what I usually do, and it depends on what you do, and depends on the application, but so there's a couple of ways how you can attach a hole to a surface. So for example, if it's, I don't know, if it's a round piece, when you click on the surface or on the edge, it's going to automatically detect the center line. If it's a square piece, you can do it with offset and stuff like that. But if you have a random set of, holes that, that has a meaning to you, but it doesn't, necessarily mean that, you can do it in a couple of ways. You can do it across a pattern. So if you have a set of points that you generate as a sketch, you can attach the holes to that sketch. So when you change the sketch, the holes will change clearly. You can make, I don't know, one hole somewhere and then pattern that hole, which means that you can do a rotational pattern or a rectangular pattern of that, So there's always a variety of different choices, and that's the beauty of softwares like this, For each operation, you probably have like 3 or 4 or 5 different ways of doing the same thing, right? That's why there is no one rule, It's like somebody prefers one way, somebody prefers another way. For example, I've done injection molding when I started doing engineering. So what was a good way back then was that you had a number of plates, and then you had guides and this and that and bolts and whatever. You could create a couple of patterns. So two sketches with points, and then when you went across all of those plates, you can just simply click on that sketch and it will create the holes across all plates, If you didn't want to use the function that SolidWorks have to automatically do holes across a number of different members, right? But there's a number of different ways to achieve the same thing, and depending on the way you're working, what your preference is, you can pick and choose the one that works the best for you. Sorry, Sri, just to give people a bit more of an overview of what's also possible.
Yeah. So here we can see I have selected the whole wizard. So here I have earlier shown a counter board. Now I will be showing another. For example, I want to create a counter sink over here. Okay. And from the standard, I want it of ISO standard. I select something like M10 or M5. I will select it. When I go to the positioning, I can select the face in which I want it. The face can be an inclined face as well. I will be showing that. So I select the face. I make control 8 so that it will be centered to me. So here I don't want, for example, I haven't created that circle over here. When I hover over the circular face, it will be showing me the center of that circle. See, I can have the center of that circle. And it is automatically placed there. This is one way of doing that. And if I'm having a point, I don't want to make it in the center. I want to have it in this point. I can again go to whole wizard. I just want to select the sketch, select the face, point. I have that point that I have created. I can do it in that point.
Can you make a circular pattern just for the sake of, giving people, an idea on how easy it is?
Yeah, sure. We will be doing it on a spline. We'll be making it.
You can do it here for the second hole, right? Now it's okay. As you had it was okay.
So now what I will be doing is like in this phase I will be making multiple points which are not even related. We can make multiple points. And
What I
yeah.
wanted is just to show a very simple circular pattern when you have the two holes in the
Yeah, sure, sure.
So
So
it-
I have this hole created now, right?
yeah,
I can have a circular pattern of this.
yeah,
Select the edge in which you need the circular pattern. Give the degree or equal spacing. How
yeah.
much you need, or you need 6. That's it. So you have 6 countersinks.
Because we
And
have advanced training for this, but it's just so people can see how
yeah,
easy it is. It's really easy to do things like this. So it's good to see.
so we have made that 6 holes pattern around this. As you see,
Yeah.
you have multiple patterning options. You
Mm.
can drive it around a curve, around a sketch. You can give a table of values. You
What,
can,
Srijit, what's the next thing planned? We having the drawing as the next thing in the training?
yeah, now what we will be having, I have completed this. Now I have shown how to edit the sketch and the features.
Oh,
Now we will be,
Shall we
yeah,
take a minute break before we hit the drawing?
yes.
Yeah. So
Yeah, we have some, yeah,
yeah, we can have some tea and we can have a
yeah,
walk and we
yeah.
come back then. Yeah.
Sure. So
So
we will
let's
be coming back after 5 to 10 minutes, right? Or 5
10,
minutes.
10 minutes.
Okay, sure.
I don't know, 11:50 ish.
Okay,
Yeah.
okay, Mr. Dijan. Okay, great.
Okay.
Bye. Bye.
Come again?
With all this upgrade from our software, our company have planned to like accept more complicated projects? Is it
Yeah, I mean, what's Srijit? Hello. That's okay. That's okay. When you're back, just I'll let you in. You're back. Okay, that's okay. So when you're back, just get back into the meeting. No worries. Yeah. Okay. No worries. It's okay. Yeah. Okay. Cheers. Hello.
Hi, Dijan. I'm extremely sorry. Our IT people are pushing some security updates. So
You know,
yeah,
technology, right?
yeah. So that system got stuck. I had to log in from another system.
It's okay.
Just give me a moment. I will share my screen. I will create that model once.
No, it's okay. We're just having a chat here just to give people an overview on
Yeah.
what we're doing.
Yeah.
I think this is where the interesting part comes in, because you can see the connection with the model going.
Yeah. So, are you able to see my screen now?
Yeah, we can. Yeah.
Yeah.
Do you have the part saved, or do you have to redo it?
No, actually, what happened? The system in which I was taking the training, they pushed the security update.
Ah, okay, okay.
So it goes to, if once the security update is pushed, then it will update, then only it will work.
Yeah.
So it is updating now.
Yeah.
So our parent company is into IT security. So what can we say?
Yeah, that's for no. Now I was just asking if you have the 3D saved or you have to redo it.
No, I was just, I made it up. That's done.
Okay. But at least you can see how fast it is now. He's gonna redo all of it. So. You can see how fast it's in real life, not on a training course.
So actually, SolidWorks is very. I've been working in the injection molding industry.
Yeah,
I was in
that too.
so I was working as a designer there, and I was into reverse engineering.
Yeah.
So you know, injection molding industry, right? Their speed is everything. Machine is waiting for the next model.
As I said, I started with that years
Yeah,
back.
it was hard there. I
Yeah,
lost all the speed after I stopped. I came into training and all. I have lost all the speed.
yeah.
But still, once you're working in manufacturing industry, your speed will be terrible. It will be very high because of the pressure.
I worked that for a while, and everybody I met wanted to go out.
It's very hard. It's very hard.
Yeah.
Then I went into reverse engineering. I'm
Yeah.
basically into reverse engineering. CAD and metrology is my section. I am into CAD and metrology.
Yeah, yeah.
So are you using any reverse engineering tools over your company?
Not at the moment, but yeah, we might want to think about that in the future, actually for castings for the corrective item.
Yeah. So we are also the official dealers of Hexagon.
Yeah.
So in case if you are going for a scanner, just remember us.
Yeah, no, I've used a scanner, in a previous company from your
Okay.
software.
Have you used Hexagon or some other?
No, Hexagon.
Hexagon is a wonderful scanner. I have been working in Hexagon for a long time now.
No, the scanner is different, but the software is Hexagon.
Yeah, okay. So we used to use a software called Geomagic. Are you familiar with Geomagic?
No.
So Geomagic is the best in line software for reverse engineering.
Okay.
So I can show you some projects that we have done after that system is turned on. So
Yeah. Since you're selling it, I can't really, take that for
no,
granted.
no. No, I'm not selling it. I'm just showing it for your information. Don't buy from us.
Okay, so that's pretty much a finished part, right?
Yeah. So I just want to add that too also. So just give me.
Now you can see, it's like that's more or less the pace, that you'll have, once you understand what you want to achieve, and you get familiar with the software and you know where the functions are, that's the speed of the work, right? Which is impressively fast comparing to making a part like this in 2D. It's a lot easier. I think the interesting part is the transition from the model to the drawing. You see how easy it is once you.
Are you sending us the recorded?
Yeah, we record all the sessions and stuff.
So that's our part.
Yeah.
Now we will be seeing how to add an appearance to this. So I want to add an appearance to this part. How can I do it? So it can easily be done.
Do you wanna go drawing first and do appearance after, or?
Just adding appearance, I will show it in a single click. I will go here,
Okay.
add part. So this will be opening up. I will select a color. That's it.
Yeah.
Appearance is added. One color. I just added one color, and now I'll be showing how we can make a drawing out of this.
So there's
we can-
two. Let's just start the clear this subject. So
yeah,
two different things clearly. One is the material. So when you attach material to a model, that will dictate its properties in simulation, its weight and everything else, because you have density, you have thermal properties, you have the weight and everything else. So when we talk about appearance, that's more like visually. When you do a model, you can change the colors, and appearance. It's also linked to the because when you do appearance, you can also select material. You can essentially go, this is a piece of metal, this is the color I want it. And what that means is that it's having in the background, it's having a definition of reflectivity of the light. So when you do a part on an assembly, when you do a photo render, you can say whether that's a piece of aluminum, a piece of stainless, a piece of plastic, and depending on that, in photo rendering, it's gonna have the appeal of a piece of plastic or a piece of metal or whatever, a piece of wood, right?
Yeah.
That's where the appearance, it's linked to, so you, based on the folder where you pick the material from and the color, it will create a very realistic photo render or, a realistic rendering of that assembly, for example. Not to be confused with the material, because the material, when you attach it, it transfers the physical properties, physical, thermal, and everything else, right, of that. So when you go on a drawing, you can then populate mass, you can populate volume, or whatever you want. What we haven't really, said on the start is that so when you make a part, when you make an assembly, or when you make a feature, because it's all mathematically defined, it has a bunch of properties in the back that you don't see, but they're there, right? So, when you do a piece of sheet metal, you can show the area, or when you do a piece of metal, you can show the volume or the weight or stuff like that. So there's a lot of properties that you can then bring on the drawing. Even then, they're not really visible to you. You can show them in a database, in the ERP or whatever else. You could essentially even attach a cost of this part and then show it later down the process when you manufacture it, so because this is, almost database driven, all the features and all the parts you make, they are almost, holding data like a database.
Yeah. So we have added appearance. So you might have seen in my screen,
yeah.
I can go to the task plane. I can apply the material. Like I have so many live materials that we are having in the real world that we can apply.
Yeah.
So we have a collection of wood, material, like glass, paint, metal. So whatever you want to add, you can add. So I just added an appearance that I want. So it is not the material, but if I apply a material here now. So SolidWorks have a tendency to change the appearance also with the material that I'm applying. For example, if I'm applying something like this steel here,
Yeah.
In steel, I am applying ISI like 304.
Yeah.
So it will also change the appearance to that. But I can change it back. Doesn't matter. The material will remain the same. I can
Yeah.
change like the appearance.
Yeah.
So this is what I wanted to show you. So now let's go. Now I have applied a material here. Earlier
Yeah.
we were not having a material.
Yeah.
Now I applied a material. So if you go to the evaluate tab, so for cost estimation and as that all will be covered in the future advanced modeling and stuff.
Yeah.
So you can have in the evaluate tab, you can see if you go to the evaluate tab, mass properties is calculated. It's showing you a weight of 462 grams
Yeah.
as per the density of this particular material I have applied.
Yeah.
So that all will be covered in the future modules, weight and how to do these things and
Yeah.
how to bring it to our bill of materials and all we will learn in our later sections. So now let's go to the drawing. So there are two methods of making the drawing. Either you can go new. So I can make an associative drawing of this part directly from here. So that let me save this. Okay, so I've saved that. Now I can do one thing. I can go make a drawing out of the part. A tab will be coming up where I have to specify what is the sheet format I'm going to use. I can use, there are the standard sheets and I can browse and use custom sheets as well. So in documents, if I have a particular sheet that I am using, I can use it, or else I can use a standard sheet as well. So I will go for an A4 sheet like this. Oh, so I have created a A4 sheet over here. Now this is one method. So this is called view palette. View palette will be having all the views of the component that we have created. This is one method of creating the drawing. There is one another method that I will show you. I'll go file, new, drawing, open, paper size it asks, and SolidWorks asks you which model you want to browse, the model that for which you want to create the drawing for. Open. So I can, in a single click, I can bring in multiple views. So for example, if I want to bring 4 or 5 views at once, I can do that. All the 4 views are created.
Yeah.
So this is one way to create the model. So, but we will do in the other way from the drawing, and step by step I will show you how to create this. We'll make a drawing out of the part. A4, but we will go with A3. Okay, and now, so in this computer, if you can see, my unit system is mmg because the template here is different.
Yeah.
So here, now let's go step by step how things can be done. So I will be creating, first I will be creating a front view or a top view. I'll bring in a front view at first. Okay, I brought in a front view. So once I bring in a view, I have different options here. Configuration is like I have told us earlier, like for a same component we can have different configuration. For example, you are having a model of an M10 bolt. The M10 bolt can be of 100 mm, it can be of 80 mm, it can be of 120 mm. You don't need to make this multiple configurations in different models. Just by changing shapes, you can save it as different configuration. We'll learn about configurations in detail. So we can select of this model what configuration it will be having, 120 mm configuration, 80 mm configuration. What configuration you need, you can select from here. You can change the view as also from here what you want to bring in, even after bringing it in. And we can come here, so we will skip this two for now, and we can come and select what shading is required. You can you want without edges, you want with edges colored, you want this shading like wireframe with hidden, and wireframe with hidden, and the hidden lines will be not be dotted. So I will basically go with this view for a front view. So once I have created a front view, I want to create the other views, right? The projected views. So I want to create the top view. So the projected views will depend upon the projection that you're having, first angle or third angle projection. So it depends on your company standard. You have to set it first. What is the projection that you use? So it can be first or third. So we will go with the third angle projection. So we will come to the projected views. In the drawings tab, we will come to the projected view. Or you can see this in the view layout as well. Okay, where there is a custom drawing tab as well as there is a view tab as well. So in the view tab, we can come here. We can select the projected view. I can select, project it. I can project another view over here. And I can keep an isometric view over here.
Let's make a section as well.
Yeah. So for this side, I don't want a projected view. I want a section view. We'll take a section. I'm having a section view over here. So this drawing, so I have made different views over here. So I have told earlier. So for this view, I want it to be a little more realistic for the person to understand how the component would look. I would make it like this, shaded with colors. Okay. Now the scenario is like, if you are doing a practical drawing, if you are doing it in AutoCAD, you need to dimension it from the beginning, from all the sizes, right? The beauty about SolidWorks is like you can go to the annotation tab. You have already made all the dimensions. You can go to the models view tab. So you want for the entire model, select. So all the dimensions that are marked as imported will be brought in. So all the dimensions are brought in. So it is not arranged in a good way. So you will select it. So it will arrange it little bit. So I want to move the drawings a little bit, up and low. But it arranges in a pretty good way.
Yeah.
Later, little bit adjustments we have to do. So leader adjustment. So I don't want this, for example, I don't want this radius to be shown in here in this view. I can press shift, drag that, and I can bring it and drop it in this view. I don't know. So we can press shift, move the dimension and move it in the next view. What's happening? Some second difference. Yeah. So if I press control, so basic command is like, if I press control, drag a dimension and put it in the other view, it will be copied to that particular view. Okay.
Which is valid for everything. So when you drag features, it also copies the features. If you do it with parts, it will duplicate parts. Control is always, when you press control, it will always create a duplicate.
So now I have shift moved, so it have copied it. So I can bring it back. I press shift, I move it, and I bring it back to this view. So press shift key, you can bring it back to this view. So there are different other things that comes with the dimensions. You can see here. I can add a tolerance value. Okay. I can say how the tolerance can be a basic tolerance, bilateral limit, and all those, how the tolerance should be, and the number of digits of the dimension. And I can also say, for if I have selected a tolerance, what is the number of digits for the tolerance?
So
that can, yeah.
Can you make the holes in the base surface? Can you make those threaded just to show how it's going to show on the drawing automatically?
These holes, right?
Yeah.
Yeah, so we have made here. So if you go
Because
back,
through
I will
holes.
make a hole in this center line. So we will be showing how it will be coming.
Yeah.
So I made a line just for reference.
Yeah.
I can do it this way also, but I just made it up.
That's okay, isn't it?
Yeah, so we go to the hole wizard, we can have a threaded hole. Okay, we have to select what is the size of a threaded hole we need. We can make it M5, position on face. Okay, so I have created a hole here. So if I go back to I rebuild this, and I don't want this sketch to be shown, I'll hide it. So I go back to the part here. So as in engineering drawing, threaded holes will be shown like this.
Yeah.
So threaded hole is shown here. I can click here, I can bring in. So I will remove the dimensions in this particular area.
You can just add one more dimension for the threaded hole. It's not a problem. Just dimension in the section or in the top
Yeah.
view.
I'll show you that threaded hole. So if I bring in the dimension, so it will be showing me what is the thread and what is the pitch.
Yeah.
And if I want to change the leader size, so I don't like this leader size, I can change the leader size.
Yeah.
How it should be maintained.
So can you change this dimension to M10, for example, or something directly in the drawing?
Yeah, so I'm having 125 here, right?
Yeah.
This dimension, I'm having a dimension over here.
Yeah.
So these are the driving dimensions. So I want to change this. I want this 125 to be 150.
Yeah.
So I rebuilt it. Let's see how it updates in the model. Changes in the model. And here I change the thread size. Let's see whether thread size will update there or not. Let's see. I have made it M5. I don't want M5. Later I decided I wanted it M10.
Yeah.
So I go back to the model. I check whether the software identifies it. Yeah, it identifies it and it's changed. And this is the associative feature of SolidWorks. So whatever we are creating there is updated here. Whatever we are changing here will be updated there as well.
Yeah. So this is the beauty of these softwares. When we say associativity, we mean a link in between the drawing and the model that goes both ways. You could change things in the model that reflect on the drawing, or change it on the drawing that reflects on the model. But when you create features that have a definition, like a threaded hole, for example, when you try to dimension the hole itself, in a top view or side view or a section view, it doesn't matter. The system won't even show that's a diameter. It will automatically show that's a metric thread, because that feature already has a definition of a metric hole. And that's the beauty of it. That's where you save a lot of time, So out of the entire drawing, the only dimension he made manually was for that threaded hole, because it wasn't there before. All the other dimensions were already there. So that's why it's so important that when you do dimensioning of a sketch and the type of modeling you do and the sequencing and that sort of stuff, if you put, a bit more effort in how you do your 3D, you can pretty much, do your drawing automatically. And that's the beauty of these softwares.
So while creating the drawing itself, if I'm marking some dimensions, there will be some dimensions that I don't want to show. There are some dimensions I want to show. I can mark that dimension as important and it will be imported.
Yeah.
That's so this is about detailing of the drawing. And I will show you something about moving the component.
We have one question.
Yeah, for sure.
Yeah, we can move it. Yeah.
You can move
Yeah.
it.
Yeah. I can move it. I can move it like, yeah.
Oh, what the question is, I think, if I understood correctly, is that the vertical piece on that protruding out of the plate, can you maybe center it to the plate just for the sake of exercise?
This one,
Yeah, the entire piece where there is this hole, can you just center it with the plate?
this hole.
No, the vertical piece
The
of
projection,
the part.
projection.
This
Yeah,
one.
That piece,
the complete piece, get it
Yeah.
in the center of the plate.
just the
Yeah, the center of the plate you want it, right? Okay.
Yeah. You can go back to the part and center
Yeah,
that.
for sure, for sure. So now I want this plate to change, right?
Yes.
So here I will be seeing, if I go and click on this part, it will be showing me it is made from a sketch. Okay.
Yeah.
I can go and edit that sketch. In that sketch, I have given this as 50.
Yeah.
Instead of giving this value 50,
No,
what I
no,
will be doing?
it's
You want
not
to make it center of this plate, right?
Yes,
center
yeah.
of the plate. I'm not
Yeah.
in the center. What we mean is center of the entire rectangular piece.
Yeah, but that's what
Yeah.
he's, but not with the dimension. It's okay.
Okay.
So what he's doing, he's making a line in between the two features and making it vertical, right? And when you update, that's what you get. So
So it is done, and we can go and check in the drawing here. It is in the center of the plate, and if you want it to be in this center,
yeah.
okay,
No, it's okay as
No,
it
no,
is.
show the other
Show
center,
also the-
other way center also.
other way center also. So that again, in that scenario, what I can do. So in this time, what I have done, I have made this sketch in this face, right?
Yeah.
So I have made this sketch in this face. So
Yeah.
instead of that,
Stop.
I will make a small change here.
Yeah.
For this feature, I'll be going here, go for the sketch. I'll change the face. I have created it in a particular face. I will remove it.
Yeah.
I will make it in this face.
So what he's doing, he's changing the sketch plane. Can you now make the extrusion go in both sides on the sketch plane?
This one. Now
Yeah.
this thread was associated with a line that I have created from this. So
No.
there is a change.
That's okay. So the extrusion for this part that
Yeah.
protrudes out, can you make it midway? Half
Yeah.
in?
Yeah, for sure.
Yeah.
So when I go from here, if
Show
I
how.
get again, I go back here from the extrusion. I want to edit the feature.
Yeah.
So I have made up to this. So I don't want like this. I want up to surface.
Yeah.
I select this face.
No, what I meant is that the feature you had before was extruded as a blind, distance.
Yeah. Yeah. Now I want it mid plane, right?
Yeah,
I
like
want
that.
it-
Yeah.
Yeah. I can do it like this as well.
Yeah.
If I make it 20, or if I make it like 40,
No, 20 is okay.
20. So
Yeah.
it will be equal from the center plane. It will be equal. So that's how the part will be updating.
Yeah.
So we can make changes at any point, and we can change the model like anything.
Yeah, but what you see now, for example, can you just stop for a sec? So
Yeah,
what
yeah.
what you see now is that, so as we said, it's a feature, defined software, right? So you have a feature and then you add a feature to it and so on, right? So before this plate, this extrusion was on the edge of the plate, which meant when you did the radius, it had, detected the edge because it was attaching to the edge, right? But now because it went to the center, you can see that the definition of the radius changed, and it didn't do a radius on the outer side of the plate because it didn't have a connection to that, and we didn't pick that yet, right? So you see that you can kind of go like, whenever you create a state, the features past that point will always be checking at the previous state, right? And then be attaching it, another feature to that state and so on and so on. Because we moved that away, now the radius changed because the definition of that feature changed before we did the radius.
Now I will show you one more feature. So I want to add, now there is no fillet in the edge, right?
Yeah.
I don't want to go add fillet or anything. I can just right click on an edge.
Yeah.
So it will be showing me the options that I can use. I can use a fillet over there.
Yeah.
I just want to give the value 3.
Yeah.
Fillet is back. So life become easy with this.
So when we say, this is a very user-friendly software, that's exactly what we mean, right? I think, and I'm not trying to make a marketing stunt, but I think SolidWorks, it's probably the most user-friendly software in the market. It's very, very to use, and you can, you have a lot of shortcuts, a lot of functions that they just give you, you click an edge and it shows you the available ones, what can be applied to that feature. Did you explain when you go into a certain feature? Did you explain when you click on it how it shows the progression of that? So for example,
breadcrumbs. Yeah, this one, right?
Yeah.
Breadcrumbs we have covered, but I can show it again. So when you click on any part or any face, it will be showing a breadcrumb explaining where and what that is. Now it is a face. That face is created because of a
It starts from sketch and then it progresses further, from the sketch to the feature to the part level, right? So you can always see in exactly, what made that happen, and you can go down the steps, in different levels, down to the basic feature that generated that, which was a section or which was a sketch or whatever it was.
And another thing is so you have created this extrusion. So if you double click on that body, it will be showing the dimensions that are related to it. So I don't even go back to the feature and edit it. I can directly change it. It is 10 here. I want to make it 20. From here, I can make it 20 and update it. So accordingly, there will be a change. So we need to know what we are creating and how our changes, how editing that we are making is going to change the model.
So just by seeing, this part, you can imagine that depending on where you put the dimension, what's your reference, it makes a huge difference, right? So when you know what you want to achieve, then you probably, know as well what's the best reference for that dimension. Because the worst that can happen is that you keep changing the part so much, you keep adding the features in, and then if you want to do a small change, the entire model falls because everything is linked wrong. And that's the biggest, concern when you do 3D modeling is that you get the models done in such a crazy way that you want to do a tiny change and then the entire tree collapses,
So I just wanted to show you a rendered image that was done in SolidWorks using the visualize package that you're having. So as we have completed the third module now. So this is the beauty of SolidWorks, and I want to show one more thing in drawing itself. So there is something called tangent edges that is created by the tangent edges. So in a physical model, we will not be seeing that tangent edges like this. So we can hide it. Sometimes if you're working within an organic shape, I think it will be mostly coming up in your models. Like you will be having so much radiuses and so much lines, which will not be good to show. We can remove it. We can go to tangent edges. We can remove it completely.
So what we can if you look at physical objects, when you have a sharp edge, there is a sharp transition. But when you have a radius, it's a soft transition because of the tangency, right? So you wouldn't feel anything if you would check the surface. When you have organic shapes, sometimes when they are designed, it's broken into a number of different surfaces, because of the definition. But when you make a drawing, sometimes you don't want to show that grid, because it's creating a bit of a problem. So you can remove tangency on certain objects. This is not the best case to turn that off because everybody would want to see that line. But there are objects which are more organic that sometimes get broken into those nice small slices. And when you make a drawing, it just looks like, it's just full of lines. You have the capability of removing those tangent edges to improve the visibility, the simplicity of the drawing, not to make it.
So we can remove it and we can hide it as I have shown now. So we can make it dotted lines as well.
Yeah.
So this is and there is one more thing I want to show you. So in case sometimes SolidWorks now from 2020 version, if there is a hole, it automatically makes a center line. So
Yeah.
in case if it is not there, you want to make a center mark there. You can select the model. You can go to center mark. You can select the model. You can say for what you want the center mark, and you can define what's the length of that. You want now it's 2.5, or you want it to be little more longer. You can make it 4 mm or 5. We can adjust that as well.
Yeah.
So center marks can be added and center lines can be added. So I'm having a hole here. I'm not having a center line. I want to show some reference for that. I can select this too, and a center line will be added. So these things are very helpful for referencing things. When you are having a complicated model, it will be very easy to reference things using this.
Yeah.
So this is all about our third module. So
Yeah.
in our next section, we will be starting our fourth module. And for the first team, we have third module pending, right?
Yeah, we have a little bit left, but we can cover it some other
And
thing.
all of you have, I think your IT team may have created for you customer portals and access to My SolidWorks, right?
The third module for them.
No. We can cover the missing part for the first group. Yeah.
He's finished with
So, yeah, it is done. Yeah. Does somebody have any questions, or are you happy with what you have?
ask as many questions as possible.
But I think when you start using it, it's gonna be easy. So Srijit, what I would suggest is that we finish with this group and we bring the first group back for I don't know 10-15 minutes.
Yeah.
You can show what they missed, right?
So fourth module can we start it on Saturday, because in the afternoon I had some installations.
I think we'll push the next session probably after New Year, but we would like to bring the first group back so we can do what we missed.
Yeah, we can do the drafting part. Yes, for sure.
Yeah,
we have to clear it. Yeah. And Mr. Dijan, I just wanted to ask you, there was do you all get access to the mysolidworks.com?
We are struggling a little bit.
So
our IT has access to it, but all the users need to get access to it as well.
Yeah,
I was trying to get my password, restored or generated, but I don't get an email from SolidWorks to do that for some reason.
Yeah, we can do that. So when you are in the evening, when you are free, just show me the scenario, and if it is still a problem, I'll raise a service request and we will fix it as soon as possible.
Is it maybe easier if I send you all the emails of all the design stuff and you just create usernames with passwords?
Yeah, actually it was far easier like this, but now I have made your IT team that way, so I will not be able to add anyone to your account.
Okay, then we'll talk with Srijit on our end.
Yeah.
No worries.
And in SolidWorks, mysolidworks.com, there is too much material to go through, and I would like to show that if you are interested, I will show you mysolidworks.com and how it can be helpful.
I would probably want to.
Yeah.
We can do that. We can do that on another time.
Yeah. Sure. Okay. So after we can start the pending section with our earlier team after 10-15 minutes. So
yeah, we can start at 1 o'clock.
Okay. Yeah? Great.
Cool.
Okay.
I think we're missing a half an hour or something like that.
Yeah. Okay. Yeah. So after 1 o'clock we can start that, and we will finish that detailing part and how it can be done.
Yeah, I'm just gonna start this session.
Yeah.
The same link at 1 o'clock, and then you go in there.
Yeah. Okay. Thank you, Mr. Dijan. Thank you all.
Thank you.
Bye.